Alrighty, hello everybody. Today we'll be talking about MEP engineering. We'll give a brief intro about it, maybe get into some of the details, but generally this is going to be more of an overall look into it and sort of a summary of it. All right, so MEP engineering. Well, you might hear that term related to the construction industry, and what it stands for is mechanical, electrical, plumbing. Okay? All right, let's get right into it. Here we've got this somewhat horribly drawn image. It's an AI image. Um, if we look at the home, we can see some elements of structure. So we see up in the roof, we see here the rafters. We see right here, we see these 2x4 studs that are inside the walls. Here we've got the floor joists. Okay, this is the beams that hold up the floor. All right. We can also see here some pipes and some plumbing elements. We've got this is what, a bidet maybe, a toilet. We've got a sink and a faucet. Okay. We see things here related to air conditioning, right? We've got an AC unit here. We've got, I believe this is supposed to show hot water and cold water piping. We can see there's some electrical elements too. And mind the horribleness of this picture. The idea, though, is that it's supposed to communicate some of the things that go into home construction. All right, and this is all relevant to the topic of MEP engineering, as we'll soon see. All right, so when we talk about mechanical, we are talking about things like thermal and energy analysis. Basically, what that means is that so in the summertime, the heat from outside is trying to get into the home, and we don't want that. In the wintertime, the heat that's inside the home is trying to get out to the cold air outside, right? And we don't want that either. When we talk about mechanical, there's also heating, ventilation, and air conditioning systems, or for short, we say HVAC. Okay, think of your window unit AC, think of your central AC and heating, things like that. There's also exhaust and venting systems. So in a kitchen, typically you'll have a hood over the stove that will take air out of the kitchen when you're cooking, right? Or in a bathroom. There also may be other venting systems that either let air in or out, depending on how well sealed and how well insulated the home is. And there's ducting systems included in that. So if you have central air of some kind for heating or cooling or both, so you've got the actual AC unit, and it's got a giant fan that pushes air throughout the house. In order to do that, you've got ducts, basically pipes, tubes, inside the house. They're usually buried in the walls or the floor, and that's what carries the conditioned air to each room. All right, electrical, all right, in the MEP refers to things like electrical load calculations, right? So when you're looking at a house and you say, okay, well, it's a 2,000 square foot house, 4 bedrooms, it's going to have things like a fridge. It's also going to have a dishwasher. Maybe it has an electrical oven and stove, depending on where you live. Some places have gas, some places have electricity. What about the clothing dryer? That also might be an electric dryer, right? How about the AC system? That's for sure going to use a lot of electricity, right? So these all they suck up electricity, right? And so we need to be able to provide enough electricity for the home. So how do you do it? Do you just guess? Do you just run to Home Depot? No, you do calculations, all right? We've also got lighting and power plans, right? So these are drawings, 2D drawings that show how, and similar to wiring and circuit protection, okay? And also diagrams. 2D drawings that show the lighting for each room, the outlets in each room, what kind of outlet it is, how many amps, what kind of protection you have, okay? If it's if it's in a kitchen area, or if it's in a bathroom area, you need something what's called a GFCI, ground fault circuit interrupted, which basically means that if water is detected, if water somehow touches the electricity, it cuts off the fuse, not the fuse, excuse me. It cuts off that circuit to prevent any kind of damage. And there's other kinds of circuit protection. All right, when we talk about plumbing, the PMEP, we talk about plumbing. So, in a home, in a building, whatever it is, we need fresh water, right? We need water supply to the general property, but then within the property, right? There's pipes that go to each bathroom, to each faucet, to each toilet, etc. Then we've got sanitary drainage and waste, right? So all that yucky stuff, we got to get it out of the home. And then in many homes and businesses or whatever it is, or properties, we also have gas, right? So it's natural gas powered clothing dryer or an oven or stove, right? And there's some other stuff, but we're not going to get into that in this video. All right, so if we jump right into the M, the mechanical, right? As we talked about before, we said that there's a thermal and energy analysis, and it also talks about HVAC systems. So the industry standard, especially for residential, there's a book called Manual J, which is produced by an organization called ACCA, right here, ACCA, it's the Air Conditioning Contractors of America. And they put out this manual. It's a book that details how to do the calculation, what methods to use, how to consider different materials and different building methods. And like I mentioned before, right, so in the summertime, we've got heat trying to get into the home. And in the wintertime, we've got heat trying to get out, right? And so in either situation, we want to protect the home from the environment. Before we get into the calculations, all right, it's necessary to understand how a home is built. Some of you may or may not be familiar. Here's some simple images. So up here we are showing, and this is a method that's very typically used in the United States and Canada. So some kind of wood member. Okay, so here in this image, these are 2x6s. 2x4 is very common. That means it's 2 inches thick by 6 inches or 4 inches deep, and then usually 8 feet tall. Could be taller. Inside of that, right here, we've got insulation. This is referred to as cavity insulation. There's usually a layer of sheathing on the outside. Okay, and then sometimes there might be another 1 or 2 layers of insulation. And then you've got some kind of external siding material. That could be stucco. It could be wood slats. It could be aluminum siding. Sometimes you'll see vinyl, okay? Or it could be brick. All right. Here we've got some other images. These are cross sections of a wall. And this is what it would look like in an architectural drawing. It's been colorized, but typically in an architectural drawing, it would not be colorized. But so you can see here, this is your insulation. This is the sheetrock on the inside of the wall. Here you've got your sheathing on the outside and your external layer, which protects from the weather and the rain. All right. All right. So I mentioned before, we talked about this Manual J for residential load calculation. It's talking about heat load and heat loss calculation. Okay. So ACCA, that's the organization that produces this manual. They have a free to download spreadsheet on their website. Okay, it's an Excel sheet and it does the calculations for you. Obviously, one needs to know how to use it, and there's all kinds of inputs that go into it. We can see down here on the bottom, there's information about the doors, like what are the doors made out of, how many doors are they, what's the size of the doors, glass referring to windows, it could be windows or skylights, that sort of thing. Okay, walls, what are the walls made out of, right? How about the ceilings and the floors, etc. Okay. Importantly, there is here so first of all, this is like an introduction on how to use the spreadsheet. There's also this README tab, which has capabilities and sensitivities of this spreadsheet. And of course, it's got limitations and guidelines. So for example, cooling in the home is provided by a central single zone constant volume system, right? So sometimes in homes, especially if they're larger or if they've got 2 floors, you might have 2 zones in a home, okay? That means one AC unit providing the heating and cooling for the top zone, for the second floor, and then heating and cooling for the bottom floor. Well, the limitation of this spreadsheet is that it can only be used for a single zone home. Now, one way to get around that would be if you were doing a manual J calculation on a 2-floor house, well, you would use one spreadsheet for the first floor, and you could copy the spreadsheet as another file, right? And then sort of repeat the process for the second floor, treating the second floor as if it were its own home, all right? I'm not going to get into the details of it. Manual J has their own YouTube channel where they go into the limitations, all right? Just another one here is that the dwelling shall have a dark shingle roof. It is interesting actually that they provide this as a limitation because using the Manual J book itself, there actually is a whole table related to the different information for different materials. And I actually think that there's a way to, I mean, I know that the Manual J has the different information associated with different roof types. So I think actually you can use it on a different kind of roof. That's something I would look into further. Then the spreadsheet starts here on this J1 form. All right, so the first thing you would do is you'd name your project. You'd pick your state and city. So we can pick, let's say, Arizona, and we can grab. I don't see Scottsdale up here. Let's grab Phoenix Airport. All right. And if we zoom in here, we can see some very critical information, very important information. Now, you're not meant to change these numbers at all. You're supposed to leave them as is, okay? But automatically, it's going to default that the indoor design heating, DB means dry bulb. That basically what dry bulb means is that you take a thermometer, like one of those old school style thermometers that's got like, alcohol or mercury or whatever, right? And you make sure it's dry, and then you use that to take a temperature in the room, okay? So now what this means is that the heating system is going to be designed to provide 70 Fahrenheit indoor temperature in the wintertime, and in the summertime, the cooling system will provide 75 Fahrenheit cooling, all right? Then this is the standard, and this is how all residential home design is done and is performed. Now, obviously, you, the homeowner, you can, set your AC to 68 or 65 or whatever it is, right? But that is actually a function of humidity, and that's a little bit beyond the scope of this topic here, all right? In the limitations, they talk about how you're not supposed to change any of these numbers, all right? Now, in Phoenix, Arizona, in the wintertime, it doesn't really get colder than 37 degrees, not really. And in the summertime, we are designing for a 108 outdoor temperature. All right. A lot of the spreadsheet has stuff that is calculated automatically. Okay, that's all the stuff in blue. The next thing you're going to do on this spreadsheet is you're going to fill out the name of each room, and then you're going to provide here the net area for the windows and doors, and the skylights, etc., things like that, walls. Now, in this video, we are not going to get into the details of this spreadsheet. That will come in a later video. The main point here being that you can see that we need to consider doors, the windows or other glass types, walls, ceilings and floors, etc., all of that. And what you get at the end is this summary page, which tells you your total heating and cooling loads. All right, now I'm going to jump to a software called RightSoft. They make software for MEP. All right, you can see here some of the different things that the features that the software can do. All right, we're going to use this for the Manual J heat load calculation. Up here at the top, we're going to select this thing here for right draw. Now, what makes this software fantastic, it does essentially the same thing as the spreadsheet that I showed before. However, it's done in a way where you draw it out, and so it's so much faster. So we're going to go over here and we're going to grab this tool, the room tool, all right? And I'm going to hold down the button and drag a rectangle, a rectangle of some kind to indicate a room, okay? This could be a kitchen, a living room, a bedroom, right? The name actually is irrelevant. That's more just for organization purposes, okay? Now, what's important is I'm going to right click and it'll bring up a properties sheet. So the first thing we want to do is right here, include in calculations. This means, do I want to include this room in the calculations for the home? And the answer is, most of the time, yes, unless it's, for whatever reason, it's a separate room. Let's say maybe it's a garage. You would not include the garage in, typically the garage is not included in the calculations. All right. There's some other stuff here, like we can set the height of the room. meaning inside, is it 8 feet, which is pretty common in America? Is it 10 feet? And there's some other stuff related to, like, so for example, the duct heat loss factor. So this is, I'm only going to just barely get into it here. This is related to, what kind of attic do we have? Where is the unit and where are the ducts? So are the ducts located in an attic? Is that attic vented or not vented? Unvented means that it's sealed, okay? Vented means that it allows in air from the outside. That means that your attic temperature is going to be very similar to the outside air temperature. Maybe the ducts are located under the home, in a basement or a crawl space, or maybe in a garage, okay? We see here garage, under the slab, exterior wall maybe, okay? So all of these things, okay, where it's located and what materials the roof is made from, okay, the color, etc. These all play into how much additional heat gain or heat loss, okay, is associated with the ducts, okay? That would be DUCT, ducts, okay? All right, now for this particular room, we are going to specify the type of wall. We're going to click over here on these three dots. It'll bring up this page here, this pop-up. So in the United States, it's most common to have a home that's a frame home. So it's 2x6s or 2x4s, okay? Sometimes homes will be, you might hear people say a block home, maybe like cinder blocks or concrete blocks, okay? So this would be like a masonry home, all right? There could be other types. Most common for sure is the frame type, okay? So what's on the outside of the home? Do you have brick? It shows brick. Do you have stucco? Do you have some kind of vinyl siding, okay, or wood siding, or wood paneling, all right? Here in Arizona, it's very typical to have stucco. What kind of sheathing is there? There's almost certainly some kind of sheathing, okay? Now, what kind is it and how thick is it? Now, I mentioned before about cavity insulation. So R11, I think, is the minimum for code, okay? It's the minimum requirement for according to building codes. I would double check that though. So that's the insulation that goes between each wood stud. And then on the interior of the wall, okay, there's most likely some sheetrock, as people call it, colloquially here, although I think that's even a trade name. The proper name would be gypsum board, all right? There could be other insulation, right? As I showed in this image here, this one, this would be additional insulation. That is done sometimes, and you would specify the R value of that other insulation. Let's talk about R value for a second, right? Because we talk about that here for cavity insulation and exterior board insulation. And it'll also appear relative to the roof and ceiling. So R, so you see R1, R2, R3, etc. Or here we've selected R11. Basically, the higher the number, it means the better the insulation. R means resistance, right? So you can imagine you want a higher resistance, which means that the insulation is better at preventing heat from passing through the wall. Okay, that's what that means, essentially. All right, we've now specified most of the relevant information for the walls. You can also change the color here. I just noticed that actually. I don't know if it actually changes any of the numbers. It doesn't actually seem to change anything. All right, now let's go to the ceiling. So what kind of roof and ceiling do we have? All right, do we have a sloped roof? Do we have a flat roof? Okay, what's it made out of? So for example, let's say we have a ceiling under an attic, like, very commonly seen, for example, like this image showed up here. Very common in the United States to have a sloped roof, okay? Especially in colder climates, where lots of rain and snow is expected, okay? In Arizona, especially in the Phoenix area, many of the homes are what's called a flat roof because there's, no snow expected and very little rain in comparison. But let's go with the sloped roof for a second. So we're going to have some kind of attic, okay? So over here on the left side, what kind of material is the roof made out of? Is it shingles? Is it asphalt shingles? Are they dark? Okay. Let's change that maybe. Does it change it? Oh, I think some of these numbers change. Let's go back. Yes, it definitely changed some of these numbers. All right. What kind of insulation do we have? does the slope roof itself have an insulation, or is the insulation part of the flooring, meaning part of the beams that would be above your head if you're standing beneath the attic? Okay, that would be the ceiling insulation. The roof, it could have its own insulation. All right, that is possible. And again, like before on the previous page, you'd specify all of the relevant information. Now, what I didn't mention before, I'll say it here, is where do you know, how do you know what this information is? Well, from the designers, the architects, as the MEP engineering team, you'll be receiving drawings that have notes and that indicate all of this stuff. You know, it should say what kind of 2x4s, what kind of studs. Are they 2x4? Are they 2x6? What kind of insulation they want in the walls, what kind of insulation they want on the roof, what kind of roof it is, etc. All of that information is in the architectural drawings. And of course, the architectural drawings don't run the calculation. That's our job. We are doing the calculations. And then lastly here on this property sheet, we've got the tab for flooring. So we head over here to these three dots, click on that. It pulls up this sheet for everything related to the floor. So what kind of floor do we have? Do we have a basement underneath us? Okay. Is it a slab on grade? Okay. That's very commonly used here in Arizona, where the foundation for the home is a concrete slab that's poured directly on top of the top layer of the dirt, the soil. All right. What kind of soil do you have? Is it light dry, heavy dry, light damp, etc.? Okay. Is there any insulation? What kind of flooring do you have inside the home? Meaning you have hardwood, do you have carpet, vinyl? You'd specify all that in here. When you're done, you can close that. Now, one little trick for this software is you can copy. I'm hitting Control-C to copy. And I'm going to copy and paste and then drag over the room. So now all the properties that I defined for room 1 are being used for room 2. If I were to drag and create a new room, now here this has the default properties, and so I'd have to go in and reset and redefine all of those different properties all over again. And in the interest of saving time, right, for yourself when you're working on the project, you're going to want to do that. You're going to want to copy over, unless for whatever reason the rooms actually were different. So we're going to copy this over, let's say a couple more times. There we go. Oops. And we can actually copy over an entire row. One more time. There we go. All right. So the home is approximately 75 feet by, we can see that up here at the top. Okay. By, looks like 40 feet. Okay. All right. If we go up here, so I can see here that this button right here for Write J has been selected. If I go over here, this pulls up the worksheet. That's the equivalent to the Excel spreadsheet, this one that we saw before. Okay. So let's click on that. Now the reason why I want to do that is, first of all,